Okay, going to make sure that this is short and sweet and that I don't babble all day. So this is part 2 of the Webhook series, and basically what I want you to come away with about this is that the relationship between an API server and a message queue is that basically what you're trying to do between those two pieces in distributing the architecture is that the API server is basically bringing in the request, and you're moving the functionality of parsing the secondary part of the communication out to the message queue. Not that you're parsing the information or anything. The information parsing and what for the resource is handled by the API server. But the communication layer of having to send everything out and wait for it to connect and what is handled by the message queue. So think of, when you think of I/O, input and output, think of input as the API server and output as the message queue. And that's the way those two pieces work together. So that's important to understand when we are talking about webhooks and moving those two pieces to separate servers and why we do that. So coming back to webhooks, let's imagine for a moment when we're talking about this infrastructure that I built here. I'm pointing to nothing here, but in this video you'll see me pointing to stuff. Or actually it's pointing over here. There we go. Now I'm pointing in the right direction. The webhooks have a pub-sub, publisher-subscriber model, like a newspaper. You know, you have all your subscribers saying, send me the newspaper when you have new information, a new subscription coming out. And the newspaper says, aye, aye, and every Monday you get a new edition of the newspaper. That's the way it used to work prior to the web for you millennials and everybody out there. Newspapers used to be published. And that's what publishing and subscribing means. For people who don't remember newspapers. And so, for instance, if we were Expedia and had a website for all this ticketing information that you subscribe to, you get a ticket for your airplane and you wait for the date and everything. Let's say, for instance, the airports like SeaTac or SFO say, whoa, that flight was canceled, or it's delayed due to weather, or, you know, terrorist attack, or you know, COVID-19. So I drew this out. So the airport, ideally, would call Expedia's API endpoints to change the data and say, whoa, we're updating this information on your servers via put, post, or delete. They'd say, we want to update all this information. I'm pointing the wrong direction again. We want to update all this information on your servers and give you the correct flight information and everything for these flights, and make sure you have the correct information. And then Expedia would say, oh, yep, we've got that information back. They send it back to the airline saying, we got it. Thanks a lot. You guys are freaking awesome. But because that was a put, post, or delete, that would activate a webhook. And as you saw, that sent it out to the Node.js front end, which was a subscriber. And that's one of the most common things to do, is to have your UI or UX front end or your mobile devices as subscribers via webhooks, so that if anything changes, it instantly gets updated. You'll see this a lot on Google Stats. For instance, if you go to YouTube, let me see if I can find this real quick. I'll pull up one of my YouTube pages. So if you go to YouTube real quick, there we go. You can see over here in real-time data, these last 48 hours of viewing. And over here in the last 60 minutes, you will see somebody pop up. Maybe I can just cause this to happen. That should pop up in about 2 seconds to say, or, you know, within 10 seconds. But they update their webhooks, like everybody, every 5-10 seconds or so to say, somebody did this. But we're going to come back to this in a couple seconds. Obviously, I just checked that out. We'll see how fast they refresh. But yeah, that's what it's for real-time updates, to say, hey, somebody just saw that and goes, and the front-end client can view that and say, hey, wow, that's really neat. Real-time statistics, real-time data, things like that. Twitter, Facebook, Google, they're big users and big believers of this. It's also really good for stuff like I just said, Expedia showing changes to flight information, things of that nature. Now, Kafka as a message queue, or a dumb message bus, is really good for this. Like any message queue, just taking that second part, the output of having to send out all those messages and wait to say, did it connect? All right, it connected, send the message. Because that takes a little while, and that hogs the threads and the processing power to just wait those couple thousand milliseconds. And the API server shouldn't have to deal with that. They should just keep cranking away on those messages and sending them off to a queue. So that's what Kafka and message queues are really, really good for. And the best way to implement Kafka is with a producer-consumer methodology. Now, a lot of people confuse producer-consumer for pub-sub. It's not the same thing. Producer-consumer is not always going to be pub-sub, which is another name for webhooks. Pub-sub, publisher, subscriber. Producer-consumer can just be a regular API call that is, going through the through your message queue. Pub-sub is specifically a webhook in 90% of cases when talking about APIs, because APIs only have one pub-sub, and that's a webhook. So producer-consumer, however, can be like all of the above. And it's really good to go this way because this takes care of all variations that you may experience. Kafka is a dumb message queue because it's really good at getting you that real-time data, but for other situations that you may also need, like to redirect and to pre-process and post-process and stuff like that, not so good. That you need just a real, actual message queue. And they can be similar speeds, but Kafka is a specialized tool wherein if you need real-time data, Kafka is the tool you use. This is why we're specifically talking about Kafka and webhooks today. Because if you need webhooks to just be real-time and available right now, Kafka is something that you use when you get to a point where you have to scale and have that immediately and precisely right now. That's why you see it used at Google and Facebook and Twitter and places like that. Because at scale, it's awesome. And if the producer creates it, Kafka gets it, and then they send it on out to the consumer, and the client reads it. Pretty easy, not too hard. Simple producer-consumer message queue. However, we should also mention that Kafka has another way to implement these, and that's Kafka Connect with CDC. And this is the one that I really don't understand why anybody would do this, but you can do it. It's right up there with many other methodologies that are kind of silly, because this is the lazy person's way to do it, and you will get into trouble with this. Now, what this is basically directly connecting to your database when any change you detect happens. It is a 5-second delay. That's the default. You can make it faster, but you will, other processing will pay as a result of it. It is not real time. Unlike with the producer-consumer model, that's going to be far more real time. The data is not necessarily going to match. Now, like for instance with our Expedia explanation before, if they change the entire flight data, it may have a new gate, it may have a new plane, it may have different seating, it won't have different seating most likely, but it may have a whole slew of different information across a whole bunch of different tables, and not just going to be one relationship with the controller and the data table. And you may just be detecting on that data table, whereas you have to knit together a object like the API server is doing on the back end from several different tables to create that object that you send back. Also, the object that you're sending back is post-processed. It may be coming back in JSON. What you have and that you're processing from a database is not coming back in JSON or XML or whatever that subscriber is wanting it in, or those subscribers are wanting it in, or that they requested it in, because they can actually request it in a format. Or based upon their role, one may be a user, one may be an editor, one may be an administrator on the back end, etc. They may get the data in different formats. Like, for instance, the administrator may get the whole string or the whole resource, whereas the user may get a partial resource. So lots of things that you would have to duplicate that your producer-consumer model is already doing for you. And it's very problematic. The only time I would ever see somebody doing something like this is if you don't own the database, it's not yours, it's on somebody else's system or it's on somebody else's network. And even then, if you have access to the database, there's no reason why you can't set up controllers for it to just set up a basic API. I mean, there's no reason for it. A producer-consumer setup is still, you could do that in a week, very, very easily. And especially it's on a separate network and a secured network. But anyway, going on, Kafka Connect. If a put, post, or delete type of situation comes in, the webhook service would detect it, make that change in the database, or make a change in the database. Kafka would then detect that change 5 seconds later and say, oh, hey, here's a hook. It would have to create that hook from a variety of tables, or create that resource from a variety of tables, send it out to the subscribers, and you get it. And that would be that.
I did check again, and there is one additional reason that you will want Kafka Connect CDC. And this is a reason where when you scale really, really high, the traffic causes you to need to put that delay out to like about a minute. So rather than every 5 seconds, you're going to be checking that database every minute or so, like we're doing here. Because you don't want, if you have millions and millions of hits and traffic checking this data, for instance, this YouTube analytics, every minute, it gets ridiculous. So they put it down to like every minute or what, so that they could reduce the traffic and just not have to be putting that out to their servers every 5 seconds. He just said once a minute, and we'll concatenate all that data and send it on out, and that's what they're doing, and it saves them a lot of traffic. So that's the reason why Google and places like that have high. They use CloudFront CDC, and they set their polling times very, very high. So they will use it and set their polling times very, very high to reduce the amount of traffic going out, and to basically bottleneck their traffic flow for real-time data, which is smart. It's a good way to do it. So that's another good reason to use that. Though there is a lot of duplication, but you can reduce that with schemas and loadable schemas. So that's a good solution as well. So I thought I'd throw that in here and add that so that people were aware of that.